Okay, so if you have not yet answered question 2 on your lab sheet, you want to go ahead and do that now. I'm assuming that you probably did if you're working through the lab slides. But if you did not, you can go ahead and pause and answer question 2. You'll notice if you did finish with all of your questions, or questions 1 and 2 at least, you're now at another checkpoint. And so what's going to happen now is DNA in the cell needs to be checked before it can be copied. We want to make sure there's no mutations, there's no issues with anything, that the DNA is healthy. And so what we're going to do is we're going to simulate that checkpoint. And what's going to happen with the DNA is we're going to make sure that our DNA is arranged by homologous pairs. And what that means is our DNA strands that are approximately the same size, you're going to notice, we have one missing, that they're kind of partnered together. We call these homologous pairs. They're called homologous pairs because let's pretend for a minute we have an organism with 3 chromosomes. You get one from mom, one from dad, one from mom, one from dad, one from mom, one from dad. And that's what makes up your total number of chromosomes. And so you get 23 chromosomes from your biological mother and 23 chromosomes from your biological father. And that gives you your total of 46. When we start the replication process, the chromosomes that are similar in size and information, they will partner themselves up into what we call homologous pairs. And that's what you see happening here. Okay. P53 is the protein that comes in and checks to make sure all of this DNA is healthy. Of course, in most organisms, there's more DNA than this, but this is the point in which that health of the DNA strands is checked. Now you are up for answering question 3 on your lab, so make sure that you take care of that before you move on.